let's take a look at another example. In this example, I ask you to evaluate double integral of f dot ds over s, where f is the vector field equals to xy, and you have y squared plus e to power xz squared, and you have sine of xy, and S is the surface, of the region E, bounded by z equals to 1 minus x squared, which is a parabolic cylinder and planes z equal to 0, y equal to 0, and y plus z equals to 2. Very good. So let's see what we have here. We're trying to compute this double integral f of ds. Let's see if we convert it into triple integral of divergence f. It helps to simplify this integral a little bit more. So what is the divergence of f? The divergence of f is partial derivative with respect to x, which gives you y, plus partial derivative with respect to y, which is 2y, plus partial derivative with respect to z, which is just basically 0. So the divergence saying that, hey, you only have a nice, beautiful function, which is simplified to 3y. So let's convert that. This guy is equal to the triple integral 3y dv over e. Well, but e is easy to construct. As you can see, your y is bounded from 0, and on top y, for example, here you have 2 minus z. It's easy to see that y is bounded between 0 and 2 minus z. Well, z is bounded between 0 and 1 minus x squared, and your x is bounded between, well, here if I said z equal to 0, x is plus minus 1, so negative 1, 2, 1. Okay, so this guy is equal to the integral 0, let's just write down negative 1 to 1, then the integral 0 to 1 minus x squared, and here you have integral 0 to 2 minus z, and 3y dy dz and dx, which is easy to compute for you. Dy dz and dx. So let us start. Here you get the integral negative 1 to 1, integral 0 to 1 minus x squared, and with respect to, let's write down 3 in front, and here you have a half y squared 0 to 2 minus z dz and dx. So this guy becomes 3 halves, integral negative 1 to 1, integral 0 to 1 minus x squared, and here if I just plug that in here, I get 2 minus z, okay, 2 minus z squared dz and then dx. So here you can use u sub, for example, you can say that, hey, u is 2 minus c and du is negative dz. So here you end up with negative 3 halves, integral negative 1 to 1, and you have a third 2 minus c to the third 0 to 1 minus x squared and dx. Okay, perfect. So far you have negative 3 halves and integral negative 1 to 1. If we plug in 1 minus x squared, you get, so we can just take this one and out and write as a third, a half, a third and third, they get cancel out. And this guy becomes 2 minus 1. So you have 1 plus x squared to the third minus, let's see, if I plug in 0 here, you get 2 to the third or 8, and you have dx. Perfect. So we are just going back to basic integration and the method that you learned in elementary calculus, all right? So this guy becomes, let's see, -1/2 in the front, and then you can write this in expanded form. -1/2 integral -1 to 1, and here you have x to power 6, and you have 3x to the 4th plus 3x squared, and here you have +1 minus 8, -7 dx. Well, okay, as you can see, all of these exponents are even exponents. So you can write it as 2 divided by 2 and 0 to 1. We have symmetry here, so we're not really worried. And then you can take this integral. You have negative, and here you have 1/7, x to the 7 plus 3/5, x to the 5 plus x cubed minus 7x. 0 to 1. So I just need to substitute 1 here. You get minus 1/7, 3/5 plus 1 minus 7, and this just becomes 0. So you should have, let's see, 184 divided by 35. So this is your final answer using divergence theorem to do the computation for a double integral.